Today's problem is a surge of 20 kV magnitude travels along a lossless cable towards its junction with two identical losses. Overhead transmission lines, the inductance and the capacitance of the cable are 0.4 millihenries and 0.5 microfarad per kilometer. The inductance and capacitance of the overhead line, this is for cable, this is for overhead transmission lines, are 1.5 millihenries and 0.015 microfarad per kilometer. The magnitude of the voltage at the junction due to surge is. This is the problem given in GATE 2003 for 2 marks. The options are given as A 36.72 kV, B 18.36 kV, C 6.07 kV, D 33.93 kV. So for this problem, a surge of 20 kV, that is V equals to 20 kV magnitude travels along a lossless cable towards its junction with two identical losses, overhead transmission lines. The inductance capacitance of the cable, that is inductance and capacitance of the cable, are 0.4 millihenries and 0.5 microfarad per kilometer, and the inductance and capacitance of overhead transmission line are 1.5 millihenry and 0.015 microfarad per kilometer. The magnitude of the voltage at the junction due to surge is. The magnitude of the voltage at the junction, that is V transmitted, when the surge travels, it will transfers, that is this is transmitted voltage. If it reflects back, this is reflected voltage. If it terminates at junction, that means from this it will travels. This is said to be the voltage at the junction, the magnitude of voltage at junction. This voltage Vt is given by V into 2 by Zc, that 2 by Zc by 1 by Zc, 1 by Z1, 1 by Z2. That is, this is the total voltage that will terminated at junction. So we have to calculate this voltage. For this, already we have Zc for cable, characteristic impedance for cable is given as square root of Lc by Cc. That is, square root of Lc is given by 0.4 into 10 to the power of minus 3 by Cc is given by 0.5 into 10 to the power of minus 6. So if we solve this, we get 10 to the power of 3 here and we get 0.8 here. That is, if we solve this, 28.28 ohms is the Zc. Similarly, for overhead transmission line, ZOH equals to square root of LOH by COH, which is equals to square root of LOH is 1.5 into 10 to the power of minus 3 by C is 0.015 into 10 to the power of minus 6. If we solve this, we get the total value as 316.23 ohms. And we have to calculate the magnitude of voltage. The voltage at the junction due to surge Vt equals to Vi into 2 by Zc by 1 by Zc plus 1 by Z1 plus 1 by Z2, which is equals to Vi is 20 kV into 2 by Zc we got 28.28 by 1 by 28.28 plus 1 by Z1 is 316.2 plus Z2 is 316.2, which is equals to 33.93 kV. This is the answer.